Hello and welcome back to the next episode. We will continue more from the last episode. So we have here the triple covalent bond. So when each bonded atom contributes 3 electrons, 3 bond pairs are involved in bond formation. 3 small lines are used to indicate these 3 pairs of electrons between those atoms. Between those atoms in the molecules of such compounds. We have 2 examples like nitrogen, N2, and ethene, C2H2. Dative covalent or coordinate covalent bond. It's a type of covalent bonding in which the bond pair of electrons is donated by one bonded atom only. The donor is the atom which donates the electron pair. The acceptor is the atom which accepts the electron pair. The small arrow is used to indicate the atom and pair of electron being donated. The head of the arrow is towards the acceptor atom. And we also have the difference of electronegativity between 2 covalently bonded atoms, which equals the unequal attraction for the bond pair of electrons between such atoms. And that's the result to the previous covalent bond, the polar covalent bond. Since previously we had the non-polar covalent bond. The difference between these is the difference between electronegatives of hydrogen and chlorine is 1.0. As the electronegativity of chlorine is more, it attracts the shared pair of electron towards itself with greater force. Partial negative charge is created on chlorine, partial positive charge on hydrogen due to electronegativity difference. It creates polarity, which is also a polar covalent bond. There's also another term. There's the delta sign, which is the partial positive or partial negative charge that is developed due to unequal sharing of a paired share or bonded pair of electrons. The polar compounds is electrons resulting from polar covalent bonds. For example, there's water, hydrogen fluoride, and hydrogen chloride. Another term is electronegativity values. They predict whether a chemical bond will be ionic or covalent in nature. Elements of high electronegativity or the halogen group plus elements of low electronegativity or the alkali metals equals ionic. Complete transfer of electrons between them. Electrons of comparable electronegativity are covalent. For example, carbon and hydrogen in methane, nitrogen and hydrogen in ammonia. Okay. There was also some more stuff that I screenshotted for notes, like the properties of polar covalent and non-polar covalent. Excuse me. There's also the effects, physical properties of molecules. We'll just do the stuff. So for the properties of non-polar covalent and its solubility in water, it does not dissolve in water. However, polar covalent usually dissolves in water. For the properties of heat conduction of non-polar covalent, it does not conduct electricity. As for polar covalence, the aqueous solution usually conducts electricity due to the formation of ions as a result of a reaction with water. And that's mostly for the topic for today, and I'll see you in the next episode.